Welcome to This Explainer. Today, we're demystifying the black box of TrustWatch AI. And honestly, we're looking at a massively high-stakes problem in the world of luxury goods right now. The luxury watch market is currently battling an absolute epidemic of what we call super fakes. These replicas have become so incredibly precise, crafted with such high-end materials and exact machinery, that even seasoned human experts are struggling. I mean, they often need to completely dismantle a watch and use a microscope just to spot the differences. Naturally, the industry has turned to artificial intelligence for a lifeline. But introducing AI brings up a really glaring problem.
So, how do you actually trust an AI's verdict? This is the fundamental flaw we call the black box issue. You feed a photo of a watch into a machine, the machine whirs away in the background, and it just spits out a simple answer like fake. But you have absolutely no idea exactly how it reached that conclusion. If you're a professional appraiser, a dealer, or a collector about to drop $50,000 on a timepiece because the computer said so, is completely unacceptable. You need proof. You need to see the AI's homework, right?
Okay, let's dive into this. Here is the watch in question. What we're investigating today is a gold Rolex-style chronograph. We're going to use this exact timepiece for a forensic case study. We're going to run it through an advanced system to see exactly how modern technology is finally breaking open that black box, turning a simple, opaque algorithm into a trusted, fully verifiable partner. Chapter 1: The TrustWatch Evolution. Hoken Tech recently announced a major, game-changing update to their platform, fundamentally shifting it from a basic calculator to a fully transparent diagnostic tool. This update rolls out a suite of brand new features designed specifically for true professionals. We're talking about the generation of professional PDF reports, visual attention heat maps, dataset alignment charts, and per-upload diagnostic plots. All of these features really share one single goal, which is making the system's deep analysis completely readable, interpretable, and well-documented for industry operators who literally have to justify their authentication decisions every single day. Chapter 2: The Investigation. So let's submit the image of our gold watch into the system under request 883DB61A, and we'll ask it to show us its entire thought process. Right off the bat, we get the top section of the new TrustWatch Authenticity Analysis Report. This PDF generation feature is incredibly important because it takes all that highly complex neural network data and structures it into a shareable professional document. Just imagine an appraiser being able to easily hand this report directly to a client, share it with a business partner, or drop it into a professional archive. It grounds all of the AI's background magic in a practical, real-world operational format. And right there, front and center on the report, we get the automated verdict. The system returned a 79.0% confidence score that the watch is a fake, accompanied by a high-risk level warning. To be completely thorough, the class scores broke down to a 79% chance of fake, a 17.5% chance of being real, and a 3.4% chance of it not being a watch at all. So the machine is highly confident this is a counterfeit. Chapter 3: The Black Box Opened. But wait, we don't just trust the machine blindly, do we? Why did the AI give this exact 79% score? Instead of leaving us guessing, the AI actually writes out its reasoning. I'll read directly from the AI's narrative summary. The serial number appears to be fabricated, and the watch's weight and dimensions are slightly off from the manufacturer's specifications. Furthermore, the watch's movement and dial details do not align with the expected design language of the brand. The system has established concrete physical anomalies here. It notes that while some features might look pretty convincing at first glance, a closer inspection reveals a whole plethora of issues. And this brilliantly illustrates exactly what we're talking about. On the left is the original photo we uploaded, and on the right is the new TrustWatch Attention heat map. See those glowing orange and green hotspots? That visualizes exactly where the neural network focused its attention to make its decision. It's actively scrutinizing the subdials, the specific text alignment, and the hour markers. You no longer have to guess what the AI is looking at. It's showing you the exact physical locations of the anomalies. Chapter 4: The Hard Data. Now, while visual heat maps are an incredible leap forward, serious appraisers require statistical proof. Let's look at the actual math. The first mathematical proof we evaluate is the ROC curve, which stands for Receiver Operating Characteristic. In simple, real-world terms, this metric shows how well the AI model separates real watch images from fake watch images across thousands of tests. The rule for reading this is super simple. The closer the curve gets to the absolute top left corner of the graph, the better the model is at its job. Take a look at the actual ROC curve chart for the TrustWatch model.
Just look at that blue line. It shoots straight up the left axis and straight across the top, hugging that top left corner perfectly. In fact, it boasts an area under the curve of 0.9999. To put that into perspective, this incredibly high curve proves mathematically that the model has historically near-perfect accuracy in separating genuine watches from replicas.
Next up, we move to the calibration curve. This one is absolutely vital. It shows whether the AI's confidence score actually matches reality. For example, if a model predicts a watch is real with 80% confidence, a well-calibrated model will actually be correct about 80% of the time. This ensures the AI isn't just out there making highly confident yet wildly incorrect guesses. Now, what's really interesting about this slide is the sheer precision. The solid blue line is our model's calibration, and that gray dashed line running diagonally across the middle represents absolute perfect calibration. Notice how tightly the TrustWatch model tracks that dashed line? That means when the system gives us a 79% confidence score that our gold watch is fake, we can statistically trust that percentage. The AI is highly calibrated to reality. Finally, we look at the prediction scatter plot. Think of it like a giant map where every single test image acts as an individual dot. Orange dots for true fakes, blue dots for true authentic watches. By plotting them all out, experts can easily spot uncertain zones and those really hard borderline cases where the probabilities kind of hover around that 50% mark. It gives us deep context, showing exactly how confidently the model separates the distinct clusters of real versus fake across hundreds of samples. Chapter 5, the ultimate support tool. As we bring this forensic investigation to a close, we really have to address the elephant in the room. Is the human appraiser now obsolete? Well, the crucial point is right here in the report's official disclaimer. It explicitly states it is supportive material only and does not replace qualified human review. TrustWatch is fundamentally designed to provide interpretive support. It arms the human expert with a level of rapid data and visual analysis that was previously impossible, but it acts as a highly advanced assistant, not a replacement. Which leaves us with this final thought. As the black box is torn open and these AI systems become completely transparent, offering up heat maps and mathematical proofs for every single decision they make, will artificial intelligence eventually evolve to replace the human appraiser entirely? Or will it simply elevate them to a state of undeniable, absolute precision? It's a fascinating future for authentication, that's for sure. Thank you so much for joining me for this explainer today, and keep questioning the data.